Good morning, everyone. I am Laila Isen, your teacher for today. Welcome to our mathematics class. I hope that everybody is doing good. Before we start, make sure you have with you your notebook, your ballpen, your calculator, and your module. For today's lesson, we will talk about arithmetic means. These are our learning objectives. At the end of the lesson, you should be able to A. Define arithmetic mean. B. Find the arithmetic means between two terms in an arithmetic sequence. Let's review first our lesson on arithmetic sequence. Let's have an activity. Fill in the blank. Fill in the blank with words that will best complete each of the given statement.
Number 1. A sequence is called an arithmetic sequence if the difference between consecutive terms is blank.
Correct. Constant. Number 2. The number that is being added in every term of an arithmetic sequence is called the blank difference. Again, you are correct. It is called the common difference. Last, the formula in finding the nth term of an arithmetic sequence is blank. It is a sub n is equal to a sub 1 plus the quantity n minus 1 times d. What are those variables stands for?
In this formula, a sub n represents the nth term of the arithmetic sequence. A sub 1 is the first term, n is the number of terms, and d is the common difference.
Now, let's have an activity applying this formula.
Given the arithmetic sequence 23, 30, 37, 44, 51, and so on until the 12th term, match what is described from column A to column B. I will give you 1 minute to answer this.
Time's up. Let us see if you were able to answer the problem correctly.
Number 1. The first term, A sub 1, is C, 23. Number 2, the common difference D is E7. Number 3, the number of terms N is A12. And number 4, the 12th term A sub 12 is 100.
I hope that you were able to recall how to solve for the nth term of an arithmetic sequence. Now, let us define arithmetic means. Watch this video.
Arithmetic mean is commonly referred as the average of a given set of data. It is computed by getting the sum of all the data and divide it by the total number of data. Hence, if I have any two numbers A and B, how will I solve for the arithmetic mean of these two numbers?
I will simply add the two numbers, a plus b, and divide it by 2.
Very good! What then is the arithmetic mean of 20 and 26?
23, because 20 plus 26 equals 46, and 46 divided by 2 equals 23.
Great! If we place 23 between the numbers, we have 20, 23, 26. Is the sequence an arithmetic sequence? If yes, what is its common difference?
Yes, it is an arithmetic sequence, and the common difference is 3.
Therefore, we can also define arithmetic means as terms inserted between two given numbers, such that the sequence will form an arithmetic sequence.
Thank you, teacher. I learned something new today.
From the dialogue between the teacher and the student, you should be able to understand this definition.
If A, C sub 1, C sub 2, and so on until C sub k, B is an arithmetic sequence, then the numbers C sub 1, C sub 2, and so on until C sub k are the arithmetic means between A and B.
Let's have examples. In the arithmetic sequence 10, 20, 30, 40, 50, 60, what are the arithmetic means between 10 and 60? Yes, you are right. 20, 30, 40, and 50 are the four arithmetic means between 10 and 60. Let's have another one. Look at this arithmetic sequence. 9, 14, and 19 are the three arithmetic means between 4 and 24. Likewise, in this arithmetic sequence, 36 is the arithmetic mean between 18 and 54. I hope that you were able to understand the definition of arithmetic mean. This time, we will learn how to solve for the arithmetic means between two terms. Let's have example number 1.
Insert two arithmetic means between 11 and 20. To solve this problem, we need to solve first for the common difference D. So if we have 11, 20, and the two arithmetic means between them, we will assign 11 as the first term, the two arithmetic means as the second term, and the third term, and 20 as the fourth term. To get the second term, we will add d to 11. To get the third term, we will also add d to the second term. And to get 20, we will still add d to the third term. So, how many d will we add to 11 to get 20? 3. Therefore, our equation will be 11 plus 3d is equal to 20. Next, solve for d. We will add negative 11 on both sides of the equation. So we have 3d is equal to 20 minus 11. 20 minus 11 is 9. Then, divide both sides by 3. So, d is equal to 3. Since we already solved for the common difference d, we can now solve for the two arithmetic means a sub 2 and a sub 3. Let's start with a sub 2. To get the second term, we will add 11 by the common difference 3. And that is equal to 14. Therefore, the first arithmetic mean is 14. Next, let us solve for the third term. To solve for a sub 3, we will add 14 and 3. 14 plus 3 is 17. So, the second arithmetic mean is 17. Therefore, the two arithmetic means between 11 and 20 are 14 and 17.
I hope that you were able to understand example number 1. You may refer to your module number 2 for more discussion.
Example number 2. Find 4 arithmetic means between 98 and 68. We will do the same steps that we did in example number 1. So we have 98 and 68 and the 4 arithmetic means between them. Let us now formulate our equation. I want you to look at our illustration. How many d will we add to 98 to get 68? Let us count. 1, 2, 3, 4, 5. Therefore, our equation will be 98 plus 5d is equal to 68. Let us now solve d in the equation. You may add negative 98 on both sides of the equation, or you may transpose 98 on the other side of the equation. Since you transpose, you change the sign. So we have 5d is equal to 68 minus 98. Subtract 68 minus 98, that is equal to negative 30. Then, divide both sides by 5. d is equal to negative 6. We can now solve for the 4 arithmetic means between 98 and 68, which are a sub 2, a sub 3, a sub 4, and a sub 5. Let's start with a sub 2. We will add the first term and the common difference negative 6, and that is equal to 92. For the third term, we will add the second term 92 and the common difference negative 6, and that is equal to 86. For the third arithmetic mean, which is our a sub 4, we will add the third term 86 and negative 6, and that is equal to 80. For the last arithmetic mean, which is a sub 5, we will add 80 and negative 6, and that is equal to 74. Therefore, the four arithmetic means between 98 and 68 are 92, 86, 80, and 74.
That's it. I hope that you were able to understand how to solve for the arithmetic means between two terms of an arithmetic sequence. For more examples, you may refer to your module on arithmetic means and series. Let's summarize the lesson.
Arithmetic means are terms inserted between two given numbers such that the sequence will form an arithmetic sequence. To find the arithmetic means between two terms A and B of an arithmetic sequence, we need to solve first for the common difference D.
So that ends our discussion on arithmetic mean. To check your understanding, do the activity on arithmetic means found in your module. See you next time.